Welcome back, ladies and gentlemen, to some more 3 equations and 3 unknowns. I realized that the other day I had my heading wrong. I wrote 3 systems, 3 unknowns, and it's definitely 3 equations, 3 unknowns. That having more than one equation makes it a system. So if you would just go back to your notes the other day and cross off systems and write in equations, that would help make your notes more exact. And I'm sure that some of you are having some struggles with this stuff. It's my favorite stuff, but it is a challenge because you really have to be careful. And like I said in the other video, double check, double check, double check. Every single thing you do, double check it. Make sure you're not dropping negatives. Make sure you're multiplying correctly. Make sure you're multiplying to every term. Make sure you're adding correctly. When in doubt, go back and check everything because this stuff works. There's only one answer to every system, but you have to be very careful while you're getting there because one drop negative, one misadding, one not multiplying to every term, any little bitty mistake is going to mess you up for the entire problem. So let's look at this next one. This is 3 equations and 3 unknowns, Messier, because we're going to get a little messier today. We've got some bigger numbers first of all, so let's look and decide which one we want to make our victim and which one we want to make our weapon. So if I look at the coefficients of x, there's not really an easy way to make 5 become 12, so I probably don't want to use those. Y's, oh, these 4's are already opposite, but there's not really an easy way to make 4 become 6. I'd have to multiply both equations, so let's look at z's. 4, 8, and 8. These ones already cancel, and this one I can just move down here. So that looks like it's going to be pretty easy. So I'm going to make my victim z. And my weapon, I am going to use equation, let's do equation 2. So equation 2 for my weapon. So in my first set of parentheses, I'm going to use equation 1 and equation 2. So to use equation 1 and equation 2, I need the 4 to cancel a positive 8. So in order to cancel a positive 8, I need this to be a negative 8. So how can I make 4 become negative 8? Well, if I multiply it by negative 2. So I'm going to put a negative 2 times equation 1. So that gives me 10x minus 12y minus 8z, and it's going to equal a positive 12. Notice all my positives changed to negatives, and all my negatives changed to positives because I multiplied by a negative. I'm also going to use equation 2, but this one I'm not going to multiply by anything because I already set up equation 1 to cancel out this positive 8z. So I've got that all going on. Now I'm going to add these together and go ahead and get my equation 4. Hopefully my z's will cancel. Yep, they do. So 10x minus 12x gives me a negative 2x for equation 4. Negative 12y plus 4y gives me negative 8y. My z's cancel, and 12 plus 3 gives me 15. Now go through, double check, like I said, double check that you wrote down everything right, double check that you did your math right, because again, one error here is going to mess you up for the whole problem. So double check, double check, double check. Then on this next one I used 1 and 2, and since my weapon is 2, I'm going to use 2 again. And this time I'm going to use 2 and 3. So 8z and negative 8z, they already cancel, so all I have to do is write them down and then add them together so I can see what I get once I cancel them. So equation 3, negative 20x minus 4y minus 8z equals 13. So now I need to go ahead and get my equation 5. Equation 5 I get by adding this set. So negative 12 minus 20 is negative 32x. Oh, look, my y's cancel and my z's cancel, so there's nothing here at all. 3 plus 13 is 16. Hey, that's going to make this a little bit easier. Now remember, if we still had x's and y's here, we would need to do elimination again by drawing another set of the squiggles and multiplying to cancel. But since my y's and my z's cancel, I'm only left with one variable here, I can go ahead and solve for it. So I'm going to divide by negative 32, and x is 16 divided by negative 32. Well, that's going to give me negative 1/2. Is this okay? Well, yep, it is, because fractions need love too. So it is okay to get a fraction as an answer. We just have to keep doing the problem until we get the whole ordered triple and make sure that it works in all three equations. So let's plug this back in. Well, I've got x. I can't plug it into any of these because they have a y and a z, and I can only solve for one variable at a time, and since I don't know y and I don't know z, just having x won't help me. I need two of the variables before I plug it back into one of these originals. This one doesn't have a y, so I can't plug it in there either. So my only option is to plug it into 4, where I know x and I still need to figure out what y is. So in equation 4, I've got negative 2, and then x is negative 1/2 minus 8y equals 15. Negative 2 times 1/2, that cancels, so I've got a negative times a negative. 1 minus 8y equals 15. If I subtract 1, I get negative 8y equals negative 16. Divide both sides by negative 8. Time out. Who did this math? Crazy, crazy, crazy. Stop it, Mrs. Black. This is why we need to double check. See, I made a mistake. What is 15 minus 1? It's definitely not negative 16. It sure is 14. So 14 divided by 8. Well, that's definitely not going to come out even. But 14 and 8 both can divide by 2. So if I divide that by 2, I get 7 over 4, and then I need to bring down this negative. Crap, that's a fraction too. But this is okay, because I can definitely have fractions as an answer. I just need to make sure that when I'm done, I check everything in my original system of equations, make sure it checks in all three of them. So now I know x and I know y, I need to find z. In order to find z, I need to plug it back into one of these ones so I have z. Well, since this has a half in the bottom, I really want to multiply it by an even number so it gives me something even. So that would be one of these two. So let's plug this back into equation 2. In equation 2, I've got negative 12 times x, which is negative 1/2, plus 4 times y, which is negative 7/4, plus 8z, and that equals 3. Let me get my numbers that I do know in place of my variables here. Negative 1/2 and negative 7/4. Now let's do some math here. 12 divided by 2 is 6. Negative times a negative, so that's going to give me positive 6. These 4's cancel, so this is just going to be minus 7. Plus 8z equals 3. If you don't believe me on this math, you can check it in your calculator, but I promise it's right. 6 minus 7, negative 1, plus 8z equals 3. Add 1, 8z equals 4. Divide both sides by 8. Oh, look, another fraction. So z equals 4 divided by 8, both even, 1/2. So my ordered triple, x is negative 1/2, y is negative 7/4, and z is 1/2. That's my ordered triple that I'm getting for this one. So now grab your calculator, grab one of these equations, and check. Then grab another equation, check. Grab a third equation, check. Make sure you check it in all three of them. I've already done this, so I'm going to skip ahead to my next example. On my next example, I've got some fraction coefficients, and don't be scared, it'll be okay, because I promise we will make them go away as quickly as possible. So on this one, for equation 1, I am going to have 1/2 x minus 5, 6y plus z, and that's going to equal 23, 6. For equation 2, I have 5/2 x plus y minus z, and that's going to equal 9/2. And last but not least, for equation 3, we are going to have negative 1/5 x plus 6/5 y plus 3/5 z, and that equals negative 6. Now I know most of you don't like fractions, and again, this is why this is called 3 equations, 3 unknowns, Messier, because last one we got fractions as answers. This one we so far at least have fractions as coefficients. So I know you don't like fractions, so I'm going to try to make those go away. So let's look at our denominators in this first one. We've got a 2, a 6, and a 6. So the least common denominator is what? Now remember I said least common denominator, not meaning the smallest number, so you're not going to pick 2. You're going to pick the number that they have in common, the least common denominator, the number that I can multiply them all by and make them go away. So the least common denominator in this case is going to be 12. Or sorry, 6. I'm sorry, I was looking at something else. Least common denominator, 2, 6, and 6 is going to be 6 because I can divide 6 by 2 and get a number, a nice whole number, and I can divide 6 by 6 and get 1. So I'm going to take each of these terms, 1/2 x minus 5, 6y plus, oops, that should be over here, plus, change this into a z, look how that worked, equals 23, 6. And I'm going to multiply them all by my least common denominator of 6. That's why I left space there. So now I'm going to cancel. 6 times 1/2, the 2 and the 6 cancel to just give me a 3. So this is going to be 3x. The 6's here cancel, leaving me with just a negative 5y. The 6 doesn't have anything to cancel here, so that just leaves us with 6z, and the 6's over here cancel, leaving us with 23. So this is my new equation 1. Now, look, fraction free. So doesn't that make you feel a little bit better about it? Let's look at let's look at equation 2 and do the same thing. So I've got 5/2 x plus y minus z equals 9/2. Notice what's the only number in the denominator. The only number in the denominator is 2, so that's definitely going to be our least common denominator. So bringing down my equation, 5/2 x plus, remember leaving some space to put in my multiplier here, 9/2. I'm going to multiply all of these by 2 to make this fraction free. So when I multiply all of these by 2, I'll get some cancellations here and here, and here and here. This will give me then 5x plus 2y minus 2z equals 9. So again, a new equation 2, now fraction free. I know your blood pressure is going down right now. I can hear it. I can feel it. Because you are getting rid of fractions and you like it a lot. I know it. So on equation 3, I've got negative 1/5, 6/5, and 3/5. Again, what's the only number in my denominator? It's 5, so my least common denominator is definitely going to be 5. I'm going to bring down that equation again, leaving some room for multiplying. Negative 1/5 x, 6/5 y, 3/5 z, and negative 6. And this time I'm going to multiply all of those by 5 because that's my least common denominator and that helps me get rid of it. Remember, you have to multiply them all by the same thing so you're not changing your equation. You have to pick one number to multiply all terms by, or else you'll change your equation and your system will be all out of whack. So that 5 cancels, so I've got negative 1x, that 5 cancels, I've got 6y, that 5 cancels, 3z, nothing to cancel there, so negative 5, or sorry, 5 times negative 6 gives me negative 30. So this is new equation 3. So now I can set this up in a system of equations using my new equations, and I can solve just like normal. So you would set up as a system, and solve like normal. I'm not going to be able to show you how to solve it because I'm running out of time. So just solve this like